So here we are with the digestive system, part 9, page 875. We have this diagram. I love this diagram because it represents an interior vision that we rarely think about or see. The stomach is missing from this view. The stomach would normally end right here at the very beginning of the duodenum. The duodenum begins here and is approximately 10 inches long. And it's also sort of hugging the head of the pancreas. Both the duodenum and the pancreas becomes retroperitoneal, behind the peritoneum, behind the lesser sac, behind the stomach, way back in the retroperitoneal area. Notice that the pancreas has a duct going through it, and then ultimately it's going to connect right here. There is a special sphincter here. I'll write in the name for you. It's the sphincter of Oddi. Sphincter of Oddi. O-D-D-I. I actually met somebody with that name. Sphincter of Oddi. O-D-D-I. And that sphincter is also hooked up here to the bile duct. The liver takes its, how shall I say, role throughout the day as the synthesizer of bile. And bile is going to come down the bile duct and join up with the pancreatic juice, which is filled with digestive enzymes. And the sphincter of Oddi is going to open and release those items, the enzymes, the fluid, bicarbonate-rich fluid of the pancreas and the bile into the duodenum here, and it's going to do that under the influence of CCK and secretin. So CCK and secretin are released from that part right here of the duodenum. And why are they released? It's because they see, or if they see, fatty, very acidic, and how shall I say, rich in amino acids type of flow through here. So we talked about that on the previous page right here. Pancreatic juices flow from all of that because of the fatty types of substances, hypertonic, very salty, and also an acidic presence. The acidic presence would be a factor of meat and wheat, or meat and grains, possible combinations. Okay, so then we're over here, and we've now joined the CCK and the secretin with this activity, the bile secretion, the pancreatic juices, and then there's going to be membrane-bound enzymes that activate all this. We'll get to those specifically. First of all, though, we should just note in general, over the big overview, is that the small intestine is approximately 20 feet long. Think about 20 feet in your mind. Look at something that's 20 feet away and realize your small intestine has a lot of area for absorption. So it begins with the duodenum. The duodenum is about 12 fingers or 10 inches long, they say. So 10 inches long for the duodenum. The second part is the jejunum, and that's about 12 feet in length. I'm sorry, it's about, 8 feet in length, and the ileum is about 12 feet. That's the longest part. The ileum is also filled with special features, sort of like tonsils or lymph nodes, only it's specific to the mucosa of the ileum, and that would be the Peyer's patches. Okay, so jejunum and ileum. So that's the general structure, and then we have a 1, 2, 3 here. There are 3 levels of modification that basically increase the surface area in order to increase absorption. The whole idea here is that we want to absorb that which we have eaten after it's been metabolized by the enzymes. So we'll talk about enzymes in a moment, but first we have to consider here the surface area. So as we go along the 20 feet of the small intestine, we begin first of all with the most gross feature, the largest feature that increases surface area, are the what's called plicae circularis, or circular folds. So plicae, or pleats as it were, circularis, these are the pleats that go around in a circle. Okay, that increases the surface area, and then on the surface there you're noticing these little bumps that when we magnify them, these are villi. And this is where we have our capillary network and also our lacteals. Recall that lacteals are capillaries, end vessel capillaries for the lymphatic system. So number 2, increasing the surface area, are the villi. In between the villi are these invaginations right here that are referred to as crypts of Lieberkühn. Okay, we'll get to that. I'll write out the word Lieberkühn for you. The intestinal crypts. Okay, the third level of magnification on each cell, the actual cell membrane is further thrown into finger-like projections, and that would be the brush border or microvilli. So this altogether maximizes the amount of surface area, so that after the enzymes work on the polymers of various types, whether it's starches or proteins or polypeptides or whatever it is, that we get down to the monomers and we absorb the essential nutrients that we've often listed on the board from time to time. Okay, so that's this section right here.